And this question has to do with law of probability number 2. Law of probability number 2. Law of probability number 2, in fact, all three laws of probability, maybe with the exception of law of probability number 1, law of probability number 2, and law of probability number 3. These two laws can be a little bit confusing. Reason being, A, terminology. It introduces some new concepts. And even the interpretation of the formulas as they're provided in the reference handbook can at times be problematic for students. So when we look at this particular question that the student is asking, I'm going to quickly go through this question. So the student is saying that I was going through the law of probability number 2 on the on-demand and I got a little bit confused because on example number 2, the first one you specifically said that P A union B is what we calculate if they use or. So either event X or Y. Because when the question states and, that was the intersection. But the following example, also example number 2 of the question states the probability of the event A and B, which I assume is the common ground between both happening at the same time. But is it union? P A union B is equal to P A plus B, and P A comma B is P A intersection B. Okay. So it can be tricky. I agree. This is actually a very simple, straightforward problem. Why? In this question, not only are you provided a problem statement, obviously, I mean, they need to give you a problem statement, but you are also given what? What is this diagram called, guys? Remember? What is this diagram called? This is called a Venn diagram. VENN, Venn diagram, which is a visual representation of the probability. Okay. So sometimes, as we've seen in the past, in other topics, in other questions that we have dissected, that we received from other students, right? What ends up happening is that some students just get fixated on certain aspects of a question and they lose track of the big picture. Correct? Now, if you ignore the question that the student is asking, the way that the student worded it, and you just, review the problem statement that the student has put together, it obviously seems like there was a mistake here. But now when we go back to the source and look at the question, the original question, calculate the total probability of events A and B using Venn diagram, right? Law of probability number 2 is also called as law of total probability. And what is the total probability of A and B? What is the total probability of A and B, guys? How are you going to define it? Is it A union B or A intersection B? In the reference handbook, what do we have? In the reference handbook, under property number 2, law of total probability, and the notation can be slightly different, right? Okay. It says P A plus B equals P A probability of A plus probability of B minus probability of A comma B, right? So the total probability of A and B. Now the student is just paying attention to one small aspect over here, which is the intersection, correct? And he gets fixated on that and then rewords, rephrases, and basically recreates a different question out of it. Calculate the total probability of events A and B. So what am I asking you to do? Probability of A plus B. Now, from a notation standpoint, different textbooks use it differently. PA union B is equal to PA plus PB minus PA intersection B, right? That's the same thing as saying that PA plus B is equal to PA plus PB minus the overlap between them, which is this, correct? Make sense? So union is or, okay, minus double counting, all right? Now, why is there double counting? I went through this derivation in the course in detail. Anyone can explain me why is there double counting? Because why don't we just leave it as PA plus B? If we go back to our basic mathematics intuition, should it not be simply equal to PA plus PB, right? Because 2 plus 4 is equal to 2 plus 4. Exactly. Thanks for your participation, Doug. And I would encourage others to also participate and provide your input, your thoughts. Okay. So if we just use our basic math 101, this is what it should be. But as I explained in the on-demand lecture in detail, if you just focus on this outline that I'm drawing in red on A. So take this entire yellow circle, okay? And you make a copy of it. Make a copy of it, Control C, and bring it out over here, correct? Now I am going to, so this is A, right? I took the entire A and took it out, right? Now I'm going to outline, highlight B. Take the entire B, make a copy of it, and bring it out here. This is B. Okay. Actually, let me just keep it a little bit separate so that it doesn't cause any confusion. So this is my entire B. Right? So this is my entire B. It's my entire A. When I am looking for all the possibilities, A union B or P, A plus B, or the total probability of A and B, I'm actually interested in this stuff, right? All of this area that is covered by A and B. But if I make a copy separately of entire A and entire B, this region, which is sort of has blue and yellow stripes, can you guys see that it is being double counted over here, right? Essentially what I'm looking for is this, A, B, without double counting this area. But now when I took the entire A and entire B, so the A has this area, and if I took the entire B, B also has this area, right? Can you guys see that how it is being double counted? That's why we remove one overlap so that we only keep one overlap, not two overlaps. Okay. So this is the law of total probability. So when we revisit this question that the student asked, the student misunderstood the problem statement on multiple fronts. And obviously that stems from what? Lack of understanding of law of total probability. Law of probability number 2. Yeah, you can make your life more difficult than it needs to be by reading too much into it, into a problem, right? By recreating a problem, right? If recreating a problem helps you in making sense of the given scenario, sometimes visualization, sketching. In fact, I'm a big proponent of sketching things out, right? So your extrapolation of a problem or your rephrasing and rewording of the problem should help you, not hinder or harm you. Does it make sense, guys? Okay. And this is a good example where a one-line problem was created into such a messy situation by a student, like an entire paragraph of defining, right? When the solution was very simple and straightforward. Any questions about this? So action items, law of probability number 1, very simple and straightforward. Okay. Law of probability number 2 is where things get a little bit interesting because you have this double counting going on. And there's a concept related to events that we discussed in both the on-demand and live training. What was that concept? I introduced a new term within the context of law of probability number 2. Anyone remembers what that was? Certain type of events. You guys remember? Mutually exclusive events. Mutually exclusive events. On a Venn diagram, I can show mutually exclusive events like this, where there is no overlap between A and B, independent. But I gotta be careful as how I use independent, right? Loosely speaking, you can say that they have no overlap, okay? Mathematically, what this means is that probability of A plus probability of B is equal to probability of A plus probability of B. There is this negative overlap overlap that we have to subtract. But what is interesting about this overlap here, guys? If you look at the Venn diagram, what is the value of this overlap? 0, correct? So in other words, when we have mutually exclusive events, we can just say that probability of A plus B is equal to probability of A plus the probability of B. So this is the definition of mutually exclusive events. Now, while we are at it, let us also discuss independent events. What was the definition of independent events? It came up in law of probability number 3. Okay. Anyone? Independent event. Can somebody give me an example of an independent event? They sort of are sound similar, right, to mutually exclusive events, but strictly speaking, they are different. Coin toss. Okay. Coin toss is an independent event, right? Why? If you do a coin toss, right, the fact that you've had a tail as a result does not impact the probability of getting tail again in the next coin toss or a head. So every coin toss, a fair coin toss, is an independent event. Does it make sense? Okay. Now, compare this. I think the example I gave in the on-demand course or maybe in the live training, compare this with the probability of drawing balls from a bucket. Starting out with the first draw, can you guys give me the probability of drawing a blue colored ball mathematically? So we can see 2 blue balls here and 3 red balls, right? Can someone give me an equation for drawing a blue colored ball? 2 by 5. So a blue colored ball has been drawn from this. So this is no longer present. This was the first draw. Second draw. What is the probability of drawing the blue colored ball? What is the equation? 1 by 4. Now, is this an independent event? Did the second draw depend on the first draw? It did. If I had drawn the red color ball instead of the blue one, this probability for the blue ball would have been different in the second round. Okay. So when it comes to probability, understanding the formulas inside out, understanding these key differences can make all the difference. A lot of students gloss over it. You might have glossed over it during your undergraduate studies, the first time you came across probability and stats. And until and unless you address it right now, it may come up and haunt you on the exam. All right. So visualization helps in probability. Terminology helps in probability. And a proper understanding of the formulas helps in probability. And if you want to learn more about preparation of FE Electrical and Computer exam and the P-Power exam, then check out these playlists over here. Thanks for watching, and I'll see you soon in the next video.